Hello everyone, we're Team Revive, and today we're here to present a sustainable tennis project, the tennis ball recycling system. Our team is consisted of avid tennis players. For us, spending too much money on purchasing tennis ball is a real concern. A typical tennis ball costs around $1.5 to $3 depending on quality and brand. Like basketball or soccer ball, a tennis ball is no longer playable once it loses pressure. Through interview and research, we discovered that out of 100 tennis players, 87 of them think tennis balls are expensive or wish it is cheaper. 85 of them think tennis ball losing pressure quickly is a problem. In addition, we discovered that each year 300 million tennis balls are manufactured and used, and 99% ends up in landfill, which is a huge environmental concern. A tennis ball has two failure modes. Either it loses pressure or it loses its outer fuzz. For most players, their ball will lose pressure way before the fuzz is used up. Average fuzz life is 4 to 5 times the pressure life. Thus, our mission is to build a tennis ball recycling system that maximizes the play value of tennis ball by repressurizing used ones until their fuzz can no longer be used, which offers a cheap, sustainable, and environmental friendly option for tennis players. We expect our customers to reduce the amount of tennis balls purchased by at least 60%. The prototype of our tennis ball recycling system consists of 3 components: a fuzz detector, a pressure gauge, and a pressure tank. The fuzz detector and the pressure gauge work simultaneously to determine the fuzz and inner pressure condition of the ball, and determine if the ball is worth to be recycled and how long to pressurize it. If we are able to recycle the ball is pressurized in a pressurized tank to pressure diffusion. A pre-recorded video is used to demonstrate our prototype. We demonstrate 3 balls in this video: a brand new ball, a used ball that can be pressurized, and an overused ball that cannot be played anymore. The first ball is a brand new ball. As it enters the station, the fuzz detector and the pressure gauge determine that it has almost perfect fuzz and pressure condition. Therefore, the gate of the pressure tank opens up, and allowing the ball to enter and storing it. The second ball is a used ball that still maintains a playable amount of fuzz but lost some level of pressure. The fuzz detector and pressure gauge determine how long is needed for the ball to recharge, and the ball is released into the pressure tank and waiting to be pressurized. The last ball lost almost all of its fuzz, thus is no longer playable. The fuzz detector determines this condition, and the ball is simply disposed without falling into the pressure tank.
This figure plots 3 bell curves for the new, old, and failed balls. Because our main goal is to find the failed balls that lose too much fuzz, we only need to focus on characterizing the overlapping area between used and failed balls. By performing some statistical analysis, we have arrived at 2 results. First, around 1/5 of the balls passed by the detector are actually non-reusable, which will slightly affect our customer satisfaction. On the other hand, we only waste about 5% of the balls identified as not reusable, which will affect our operation cost. The second component is the pressure gauge, which is mainly made by a press and a force transducer. These figures plot the distribution of force transducer readings for new and used balls. We could see that the mean values and bounds are significantly different from each other. This helps us to discriminate whether the ball needs to be pressurized or not. The last, but also the most important component is the pressure tank, where all the pressurization of the balls takes place. Because it is impossible for us to directly measure the inner pressure of a tennis ball, We put a weight on the ball and measure its deformation, which is directly proportional to the inner pressure. The figure shows the deformation of used tennis ball when they are pressurized under 32 psi for a certain amount of time. Because the marginal return in inner pressure gradually decreases as pressurizing time increases, we find out the maximum pressure time is 3 weeks. Based on this curve, we can also design our criterion for how much time is needed to efficiently pressurize a ball. Thank you for listening.